Uncovering what Earth looked like 3.8 billion years ago. How did our solar system look in the past? Were the planets the same way, or were they completely different? In this video, we will travel back in time to see how our Earth looked like, so stay tuned. But before we go any further, I'll request you to subscribe to the channel. Thank you! Let's start off from an interesting premise. Why did we choose 3.8 billion years as our baseline? The reason is that, around this time, the solar system entered a period known as the Late Heavy Bombardment Period. Between 4.1 and 3.8 billion years ago, a huge number of asteroids collided with the planets and other celestial objects of the interior solar system. These collisions may have been critical in giving our solar system the shape it is in. But let's just begin with gas planets and how they looked 3.8 billion years ago. Gas planets are a good starting point, since they are not impacted as much due to an absence of a solid surface. Late into the bombardment phase, Jupiter, Saturn, Uranus, and Neptune had many asteroid impacts, but remain unaffected since these asteroids were buried deep beneath their gas clouds. Astronomers have maintained that Jupiter and Saturn may have changed their colors slightly because of the minerals found in the asteroids. When these minerals were absorbed by the planet's atmosphere, it would have some impact on the overall tint of the planet. Evidence comes from an impact made by a comet, codenamed Shoemaker, on Jupiter in 1993. This impact created a dark vortex on the planet and also changed the composition of the clouds to some extent. But the point remains that most of these changes were superficial at best, and for the most part, gas planets looked the same way back then as they do today. However, the same is not true for their moons. One thing is for sure, these planets did not have as many moons back then. We know this from the fact that the icy giant, Neptune, captured this moon since it was not originally a part of this planet. Now, let's talk about rocky planets. Rocky planets had a completely different scenario. For instance, Mercury, 3.8 billion years ago, looked like a fire pit. Now, the MESSENGER probe has shown that instead of being a fire pit, this planet's surface looked more like the moon's surface after collision with a variety of asteroids, some only being a few meters in width. Others have a surface area of thousands of kilometers. Some of the craters left by the meteors are somewhat recent, only million years old, and can be seen with a central peak. The day and night temperatures of Mercury fluctuate wildly, between 350 degrees Celsius at day and minus 170 degrees Celsius at night, due to an almost non-existent atmosphere. Most of the meteorite impacts could be dated back to 4 billion years ago, when Mercury was volcanically active, and the resulting lava produced smooth plains, today captured in footage, detailing compression folds crisscrossing the plains. Due to its proximity to the Sun, the tidal forces are 17% stronger on Mercury. Next up, we will discuss Venus. Venus has often been referred to as the twin planet of Earth, but apart from outward similarity in terms of size, there are no other parallels between the two. Venus is the hottest planet of the solar system, with temperatures reaching 480 degrees Celsius. Sulfuric acid rains are very common on Venus. One important reason, which may explain its hellish temperatures, is the predominance of greenhouse gases, because of which a thick insulation covers the planet. But despite how different Venus and Earth are today, scientists think Venus may be extremely close to Earth billions of years ago. Many comets fell on Venus after the bombardment period came to an end. Now these comets are huge bodies of ice and carry huge reservoirs of water. When these comets crash on planets, the ice melts, and if the planet has some gravitation, the accumulated water could eventually transform into oceans and lakes. Back then, the temperatures were very moderate, reaching up to 50 degrees Celsius. This means that if we go back in time, Venus may have had conditions conducive to life. It is estimated that Venus, for the next 300 million years, could have supported the water resources. However, something caused a buildup of carbon dioxide, which led to the gradual rise of temperatures. This means that water may have evaporated continuously until it finally disappeared from Venus. Now Venus is the hottest planet in the solar system, and for that reason cannot support life. But was Earth as beautiful and capable of supporting life 3.8 billion years ago? 3.8 billion years ago, Earth looked very different and was entering the Archean Eon. During this time, there were many tectonic shifts, and unregulated plate movements within the Earth's surface, accompanied with excess amounts of heat. Scientists also think that back then, there was more seismic activity on the planet, since the lithosphere was rapidly being produced. Due to the frequent seismic activity, the volcanic activity was also on the rise, which led to an accumulation of greenhouse gases. There was no trace of oxygen in the environment back then. Also, scientists think that the sun was not as bright back then as it is today. This may have resulted in an overall decline in temperatures all across the solar system. This time is known for having the highest volume of greenhouse gases at any time in Earth's history. We have uncovered fossils of organisms which thrived in carbon dioxide back then. These organisms could have been responsible for producing oxygen in the environment today. We will discuss Mars and how it looked some 4 billion years ago in another video. This brings our video to a close. Please give this video a thumbs up if you like the content. Thanks for watching till the end. See you in the next one.